Hi, in this set of lectures we're talking about models of culture, why we see differences between different cultural groups and why we see similarities within. To make sense of cultural differences, we're going to construct a very simple model called the pure coordination model. That's going to be the basis of much of what we do in this set of lectures. To understand the pure coordination models, I want to give some examples. So we're going to start with something I call the ketchup question. The ketchup question goes like this. Where do you store your ketchup? Do you store it in the fridge or do you store it in the cupboard? Now you're going to find that some people, most Americans, store their ketchup in the fridge. But other people, people from England, tend to store it in the cupboard. So where you store your ketchup is a cultural decision. You store it in the same place that your people store their ketchup. So if your parents store their ketchup in the cupboard, you probably store it in the cupboard. If your parents store their ketchup in the fridge, you probably store it in the fridge. This is an example of a coordination game, a situation where you want to do the same thing that other people do, otherwise they can't find the ketchup. That's the idea. Now, ketchup is only one example. Think about electrical outlet plugs. If you go to Europe, it seems like every country has their own little plug configuration. It may look like this, or like this, or like this. And when you can go from one country to the next, you need some sort of converter. Otherwise, you can't plug in your computer or your hairdryer and stuff like that. That's an example, again, of a coordination game. Everybody in the country wants to coordinate on the same plug type, but different countries can coordinate on different types of plugs. Now, the ramifications of failure to coordinate can be rather severe. So this is the logo for something called Dagen H. And what happened is on the 3rd of September in 1967 at 4 o'clock in the morning, I think 4:45 in the morning, in Sweden, they switched which side of the road they drove on. So they used to drive on the left, and then everybody switched to drive on the right. Now, they did this in the middle of the night because they thought nobody'd be on the roads. But the exact opposite happened. A whole bunch of people were on the roads, and they all then slowly switched sides and then took off driving. Now, the reason they did this is that if everybody from Sweden, if people in Sweden never drove to any of their country, it would be fine. They could all drive on the left, and people from other countries could drive on the right. But if people from Sweden drove to other countries, and then they ran into someone else, they literally would run into someone else. It's also the case that if you're making cars, it's a lot easier to make cars with steering wheels on the same side. Now, it's still the case that not every country drives on the same side, right? England, they drive on the left, right, as well as several other countries. And those other countries tend to be former British colonies. They also tend to be islands. If you're on an island, you don't have to worry about crossing a country border and running into someone you don't want to run into. That's a coordination game. So what we want to do is we want to take that idea and turn it into a formal game. So what is a game? A game is a set of players, they have actions, and there's payoffs. So here's the pure coordination game. There's two players. There's player one, and there's player two. Each one has an action. They can put the ketchup in the fridge, or they can put the ketchup in the cupboard. If they both put their ketchup in the fridge, both get a payoff of 1. If they both put their ketchup in the cupboard, both also get a payoff of 1. But if one of them, player one, puts it in the cupboard, and the other one puts it in the fridge, then we're down in this box, and player one gets 0, and player two gets 0. Because neither one can, they go to find the ketchup and they can't find it, so they run to the store and have to buy ketchup. So if you put it in the same place, make the same decision, you get a payoff of 1. And if you make opposite decisions, you get a payoff of 0. Now stick with me for a second, because culture is an incredibly complicated thing, and I'm trying to explain it with what looks like a really simple game. And that's true, but what we're going to do is we're going to expand the game. We're going to start simple and build up. So now let's think of this pure coordination game as comprising a whole bunch of people who all have to decide ketchup fridge, ketchup cupboard, or left side of the road, right side of the road, things like that. And let's color one of those decisions blue and the other color yellow. And now let's think about each person. So if we have this person right here, let's suppose that they play this game against these two people. Well, this person now realizes, look, I'm doing the opposite thing of these two other people. I just moved into a house with these two friends, and they both store their ketchup in the cupboard, and I'm storing it in the fridge. So what they may decide to do is change their behavior. And this person over here is between two yellow people who's blue may decide to change their behavior. So what you're going to see is people, because they want to coordinate, changing their behavior to match other people. That's going to create the similarities within the fact that we're playing these coordination games. It doesn't matter really what color shirt I wear. I could wear blue, I could wear plaid, I could wear green. But it does matter where I store my ketchup. It does matter which side of the road I drive on. It does matter how I greet people. Because I'm in those situations, I'm coordinating, I'm playing a pure coordination game, and I'm going to end up matching. If they're doing blue, I'm going to do blue. If they're doing yellow, I'm going to do yellow. Well, now we can ask the question, suppose that's going on. Suppose there's these pure coordination games. Does that actually lead to similarities? Does this process stop, or do you just get this churning and churning and churning? Well, we can answer that by going back and looking at the Lyapunov functions. So remember, Lyapunov function said it's a function f that has a minimum or a max. Let's say in this case it's got a max, and it goes up by some fixed amount each time if it moves. And if we have that process, then we know that the process is going to stop. At some point, this process is going to stop. Well, it turns out if we play the pure coordination game asymmetrically, that means having each person moving one at a time, you can show that it satisfies the Lyapunov function. How do we do it? We do it by letting the Lyapunov function be the number of coordinations. So suppose this person right here switches and becomes blue. What's happening is the number of coordinations has gone up by 2, because now this person's coordinating with this person and with this person. So if people are in a long line, what you're going to get is each time someone chooses to match the people next to them, you're going to get an increase in +2. Well, that's going to work just like Lyapunov function. Every movement increases the number of coordinations by 2. There's a maximum total number of coordinations, so the process has to stop. Now, the process doesn't have to stop, though, with everybody being the same. You'll notice here you could get a boundary where everyone on this side is blue and everyone on this side is yellow, and nobody wants to change what they're doing. So depending on the social structure, and we're going to come back to this when we look at Axelrod's culture model, you may get everyone doing the exact same thing, or you may get blocks of people doing very different behavior. And that's, again, will help us explain why we sometimes see differences between countries. One other thing I want to deal with here. How do we separate coordination from the standing ovation problem? Because in the standing ovation model, remember, people were doing the same thing that other people were doing. And here I've made that a formal game with payoffs. What's the difference? Is there a difference between standing ovation model and the coordination game? There is, and here's the difference. In the coordination model, there's a measurable difference in your path. As an outside observer, you can say, it's very important that you drive on the same side of the road, because otherwise you're going to crash. In the standing ovation model, it's more of a psychological effect. Like, you sort of want to do what the other people are doing, but you don't have to. So remember, in our standing ovation model, you may not stand if other people are standing. You could decide, well, I don't care. I didn't like the show enough, I'm not going to stand up. But in terms of choosing which side of the road you're going to drive on, you're going to pay a huge cost if you don't drive on the same side of the road as other people. So we think of coordination games as situations where there's a direct, measurable payoff, a physical effect. And we think of standing ovations as being cases where the more people that do it, the more likely you are to do it, but you wouldn't have to do it. You still don't have to do it. So again, dog and H, you've got to choose the same side of the road as the other people. That's a coordination game. Now, one last thing on this before we move on and start expanding this to a full model of culture. I want to talk about inefficient coordination. When we talk about culture, we said there's differences between cultural groups, similarities within, and this now model gives us an understanding of why there's similarities within, because we coordinate. There's also interesting behavior, stuff that doesn't seem optimal. And we can ask, why is that? How does that happen? Well, to make sense of that, I'm going to introduce a slight variant of the pure coordination game that's known as the inefficient coordination game. And I sometimes use something I call the Maui Des Moines game. So Maui is in Hawaii. It's a beautiful place to go on vacation. You can snorkel, there's great fruits, golf courses, it's incredible. And Des Moines is a lovely town in the center of Iowa. It's a great place. And it's also a nice place to go on vacation, but it's not as nice as Maui. And even though I lived in Iowa, I love Iowa, it's not as nice as Maui to go on a 2-week vacation. But suppose you and your partner win a vacation, but there's a catch. The catch is you've got to decide to go to the same place, because otherwise it's not going to be fun. And you get to the airport, and you can't remember, are we supposed to go to Maui, or are we supposed to go to Iowa? And so what happens is you're thinking, okay, if we both go to Maui, we're both going to get payoffs of 2. If we both go to Des Moines, then we're both going to get payoffs of 1, because Des Moines is a nice place to go, and we'll get to spend a vacation together in Des Moines. That'll be fantastic. If person 1 goes to Maui and person 2 goes to Des Moines, we get payoffs of 0. Or if person 2 goes to Maui and person 1 goes to Des Moines, we get payoffs of 0. So if we go to opposite places, even though one of us is in Hawaii and one of us is Des Moines, our payoff is 0 because we're not spending a vacation together. And that's really what we wanted to do. So Des Moines is nice. Maui's even better. And so you think, well, duh, we're going to go to Maui because the payoff is 2. But that's not always the case. So what you see here is a chart of the English system of measurement. So you've got things like foot and yard, which we all understand, but then we've got fathoms and shackles and cables and grades and shaftments and fingers and picas and barleycorns, which no one has any idea what they are. This is a mess. And I live in a country that does this, that we have the English system of weights and measures. We can take our Maui Des Moines game and I can just cross out these D's for Des Moines and put English system of weights and measures. There's an alternative. We could all use the metric system, which goes in units of tens, right? There's meters and decimeters and millimeters and kilometers. Everything's wonderful. It all makes perfect sense. And I can get rid of yards and fingers and picas and barleycorns and all that stuff. But in fact, I'm stuck in this place where we're all using the English system of weights and measures and getting a payoff of 1 when we can move to metric and get a payoff of 2. But the reason we don't move is because everybody else is using the English system of weights and measures. So everybody else is saying, this person's 6 feet tall, or this person's 8 feet tall, or it's only 5 miles away. Since no one else is using kilometers, I have no choice but to also use the English system of weights and measures. And as a result, I'm stuck in this inefficient world. How do you get inefficiency? This doesn't make any sense, because why didn't we just choose the metric system? Well, the metric system wasn't around is one reason. But the other thing is situations can shift. So to explain this to my undergrads, I often use the shake-bow game. So think about when you're greeting people. Here's a coordination game. It's important that we greet people the same way. If I shake and you bow, I poke out one of your eyes. So what happens? If we both shake, then we get a payoff of 1. If one of us shakes and one of us bows, we both get a payoff of 0, because again, I'm poking out your eye or you're poking out my eye. If we both bow, here I'm going to give a payoff of A. Now the question is, which is better, bowing or shaking? Now I could make an argument that A is less than 1, that shaking is better than bowing, and the reason why is I get a sense of your general health by feeling, whether your hand is warm or cold, your strength. We're actually touching each other. We can look each other in the eye. There's all sorts of reasons I could say where shaking is better than bowing, and A is less than 1. And so therefore, bowing is inefficient. However, I could also make the case that A is bigger than 1. And I'm even going to make the argument that recently the value of A has increased. And the one reason the value of A has increased is because people now travel all over the world, and when you're on an airplane, there's all these germs all over the seats. And when you touch the seats, you're getting these germs all over your hands. And then when you go meet somebody else, you say, here, I've just been in a sealed container for 4 hours with a whole bunch of people I don't know. I would like to hand you their germs and viruses on my hand. Here you go. That's horrible. So, in fact, you can either think of the 1 as getting smaller, or relatively speaking, the A getting bigger. But if you think in terms of communicable diseases, bowing may be better than shaking. And because the world has changed, bowing may be becoming more better every day. Maybe it's better to bow than to shake. Maybe say, very nice to meet you, as opposed to say, here, take my germs. And as a result, countries that are shaking could be stuck in a suboptimal way of greeting, just like I'm stuck talking about pints and cups, as opposed to talking about liters and deciliters. So now we have some understanding of how we get similarities within a culture, because people have to coordinate, and we get some idea of how we get interesting behavior, because sometimes we coordinate another thing that isn't the right thing. If you go to Des Moines instead of Maui, we use the English system of weights and measures as opposed to the metric system, and we shake instead of bow. What we want to do next is talk about how we get these differences between cultures, and also we want to expand the model by getting an understanding of why cultural behavior is so rich, as opposed to just single things like driving on the side of the road. Okay, thanks.